Hey guys, and welcome to one of our two example videos for function transformations. So this first one, what we're going to do is we are going to practice transforming an absolute value function, and the same principles will apply to any function that we deal with, right? So as we talked about in the lecture video, when we're talking about transforming functions, we always want to refer back to the parent function. And in this case, our parent function is this one here, f of x equals absolute value of x. And that is the graph drawn right here. So what I've done, is I've created the second function, g of x, which is equal to negative 2 times the absolute value of x plus 1 plus 5. Now, what this will do is this will allow us to practice our function transformations on a function like this. Now, functions like this are really easier to transform because it has this unique point here. And by being able to track that unique point and maybe at one or two other points, we can really kind of identify kind of what happens with this graph. And so what I want to do is I want to identify two other points that will help us out. I don't want to necessarily identify 2 points on one side because those are both going to do similar things. So I'm going to go with these 2 points here, okay, which are 1, 1 and negative 1, 1. So with negative 1, 1, 0, 0, and 1, 1, we are able to then kind of build this out, because if we know where these 3 points go, then we just connect the dots and we know what this graph looks like. So the first step in doing this is identifying all of our transformations that are happening here. So if we look at what we have here, we actually have 4 unique transformations, 2 of which can be combined into a single step. Okay? So if we just look at it from left to right, okay, we see that we have negative and a 2, right? So that's our kind of 2 that can be done at once, right? We have a reflection and a scaling. We are adding 1 here and we're adding 5 here, so those are 2 different shifts or translations. Okay, so when I'm looking at this, trying to figure out kind of where we go, what each one is, whether it's horizontal or vertical, right? That was really easy when we had kind of function notation, right? If I define g of x in a function notation using f of x instead of absolute values, we could be like, oh, it's inside the parentheses and this and that. But if we look at the way this is defined, because it's defined like this, these brackets, these absolute value signs, kind of act like a parenthesis. And so in that case, it tells us this plus 1 is a horizontal shift. All the remaining transformations, they happen outside of the absolute value, which was our original function, was absolute value. So that means they happen after our original function, so they are vertical transformations. So these 3 things, so the reflection, the scaling, and this plus 5, all represent vertical transformations, whereas this plus 1 gives us a horizontal transformation. Now, what order do we do them in? Do we just go left to right? We flip it, double it, shift it over, shift it up? The way we do everything in math is all built off of a nice little acronym. Now, you may have heard this, you may not have, right? But it's PEMDAS. Now, if you kind of learned math in other countries, you may have heard BODMAS, it's similar ideas. I believe BODMAS, yeah. So basically, right, parentheses, exponents, multiplication, division, addition, subtraction, PEMDAS. Now, when we're talking about that, when we say parentheses, we don't just mean only parentheses. It really means parentheses or grouping type symbols. And an absolute value sign is a grouping symbol. So we have to do whatever's inside here first, and then we can branch out. So that means when I'm doing this transformation, I first have to do this horizontal shift. Okay? Now remember, horizontal shifts, horizontal transformations in general are counterintuitive. So that means since this is adding 1, we are not moving in the positive direction 1. We are actually going to move in the negative direction 1. So this is a horizontal shift to the left 1 unit. So what I'm just going to do, we're just going to kind of graph each piece of this a little bit at a time, and I'll just kind of dotted line this. At the end, we'll fill in one solid bracket, or one solid graph. I just want to move all of these points to the left 1. Now, I'm not moving them up and down. I'm not changing their vertical anything. All I'm doing is going to the left 1. So this point here, that's at negative 1, 1, goes to the left 1, negative 2, 1. 0, 0, negative 1, 0, and 1, 1 goes to 0, 1. So now, that's what we have. Okay? There is that first part. Now next, after we dealt with our parentheses, we need to deal with any exponents. There's no exponents here, so we're good. So now we need to deal with any sort of multiplication or division. With our multiplication and division, we have this multiplied by -2. Now, once we get kind of some practice, and in this next example video that I'm going to do, we're going to kind of break this down and do a lot of these to get us that like kind of repetitive practice. We'll be able to easily do this at one time. But right now I want to do this kind of separately. I want to do our multiplication, our scaling, and then I want to reflect. So the first thing, we're multiplying the output of this function, right? Because we're now vertical. We're going to multiply it by 2. So that means we're going to take these points and we're going to stretch them out vertically. We are going to take the output and double it. So at -2, 1, that's going to go to -2, 2. At -1, 0, well, the output is 0, so it stays the same. And at 0, 1, the output's doubled, so that goes to 0, 2. So now this is here. Okay. Essentially what that did is that changed the slope of these two, right? It kind of took it like this, and it made it look like that. Okay. Now you may be like, is that just a vertical shrinking? And with some functions, like an absolute value function like this, especially if it's on the origin, right now it's not exactly, so it's a little different. You can actually do a vertical stretch and a horizontal shrink the exact same. They can be the equivalent transformations, just require some number manipulation. So let's focus on this though, what we've got. So we've dealt with that too, right? So it's vertical transformation, so it only affects our outputs. Now we're going to do this vertical reflection. So what's going to happen is this graph that's up here is going to be reflected down to here. Okay? We're reflecting this, we're taking this y-axis, if you will, and we're flipping it over, right? Which means this top part comes down here, bottom part goes up there. And mathematically, the way we can think about it is we're taking the outputs and we are multiplying them by a -1. So if we're at -2, 2, the output is a 2. So I'm going to multiply that by -1, and -1 times 2 is -2. So this point that was up here now is here. At -1, 0, the output's 0, so it just stays where it is. And then at 0, 2, multiply the output 2 by -1, and we get 0, -2. Okay. So as you can see, we could have kind of done that simultaneously by taking these values here, right? We multiplied by 2, then we multiplied by -1. We can very easily just take the output and multiply it by -2, and we would have gone from -2, 1. 1 times -2 is 2, so we would have been at -2, -2, which is where we are. So that's another way we can kind of shorten this step up, and again, we're going to get more practice doing that in the next example video. So we've taken care of our horizontal shift. We've taken care of our vertical scaling. We've taken care of our vertical reflection. The last thing is to take care of our vertical shift. All we're doing is adding 5. Remember, vertical transformations act intuitively. They act the way you think they're going to do. So if you add 5 to something, it's going to go up. So I take each of these points, add 5 to their output. So this point here is -2, -2. So if I take that output -2 and I add 5, right? I go 1, 2, 3, 4, 5. I'm now at the point -2, 3. So when you're -1, 0, I add 5 to 0 and I get 5. And lastly, I'm at 0, -2, add 5 to that, and I am at 0, 3. That's it. That's our final. So that means the final transformed version of this graph looks like that. Okay? Kind of. This is not something you would do in anything. This is just something that I'm doing because it's kind of hard to see. Normally I would use colors, but I don't have colored chalk. So you can see this scribbled graph is our transformed version. Hopefully that makes sense to you guys. Typically I don't like to transform a function entirely as its whole function. Notice what I did is I just picked 3 points, transformed those points, and connected the dots. We're going to expand on that in this next video. We're going to really work on thinking just focus on these points, and we're going to do a totally weird function that doesn't even have an equation. So, with that, I will see you guys in the next video.